Hey you guys, in the previous video we created our cubed class and it was very similar to rectangle. So one thing that we're going to start doing now is that, well, we've established the context and problem of having two classes that are very similar to each other, and pretty much cube would benefit if it could just get all of what rectangle is, if it could inherit all of rectangle into itself. The solution to this is, well, object-oriented programming. Here we're just going to convert our rectangle class into a base class. And what's super amazing about converting our just regular rectangle class into a base class is that all we have to do is edit the header file. So we have already gotten started by changing, well, it's supposed to be private here to protected. So we have that done. And we don't need to do anything with the attributes, and we don't need to do anything with the constructors. But with the destructor, well, it's good practices to do something called making a virtual. And what this is going to do is that this makes it so the cube class is going to inherit the three constructors, and it's also going to inherit the destructor. Why do I make the destructor virtual? Because in some cases I will need to change my destructor, right? So there's different possible combinations. So since rectangle is a base class, there might be something where I need to do something special in the destructor. Let's say, for example, if I allocate memory, that needs to be specifically inherited for the cube class. But at the same time, if rectangle only has static data and the cube class gets dynamic data, right, where it needs to do some dynamic memory allocation or something like that, it will need to do something called override, and it'll need to override the destructor of its parent class. When we override the destructor of the cubed class, what that means is that it's going to call the cube class destructor first, and then after it's going to call the rectangle classes destructor. If there's any dynamic memory allocation, or if there's something special in particular that we need to do in the destructor, we first clean up the cube class, and then we move up a level and clean up the rectangular class, right? So what does this really mean? Well, when you put the virtual keyword before a method, it means that you are expecting it in the future that whatever class inherits this, that they may need to modify the nature of how this works, or they need to add more functionality. It's kind of, think of it as like method overloading from a parent class. This lets our derived classes, in this case which will be cube, have the permission to overload the destructor and add additional functionality to it if need be. So when you have a method that you think could change over the future with derived classes, make sure you make it virtual. Luckily for me, after this, I don't really need to set the getters as virtual. They can remain the same, as well as the setters, because they're just going to apply for the inner workings of the rectangle class. However, here I will need to make my void function a virtual. The way I print in rectangle can mean one thing, but in cube, right, I'm going to have to introduce my additional attributes into the print method. So it'll benefit that I inherit this print method from rectangle, but I will need to change it. So in anticipation for that, I'm going to make my print virtual. And something to note is that with your base classes, you're not always going to know what's going to be virtual right away. I could find out that later as I create my cube class that I need to go back and, make, calculate area virtual for some reason, right? There's no problem with doing that. You're not always going to know which methods are going to be virtual. You can try to anticipate it, but I can say with confidence that you should always make your destructor virtual. Always, always, always. Just like you should always have an equals operator overload for your class, you should always make your destructor virtual for your base class. And actually, because our base class is so simple, we're pretty much done with turning it into a base class. So this is awesome because we didn't need to edit rectangle.cpp at all. We just needed to update the header file, so that way when our future class cube inherits from rectangle, that it knows what methods are going to be virtual, so that way it could update them and edit them and make them something new if it needs to be. the cube class is going to be able to inherit all of this data, including the friend function as well. So that way, some of this stuff I won't have to re-implement, namely these getters, these setters. It'll let me use these attributes and methods if I'd like to, and that kind of thing. Like, I can use these as well. There's no problem with that. And that actually wraps it up for converting our rectangle class, which was an independent class, and it is now a base class. So the next video, we're going to transform cube from an independent class to a derived class where it will inherit from rectangle.